Another draft physics presentation. Yeah, there's always some issues. The sync gets off on the camera, but it's different each time I load the software, so it's just kind of funny that you have to adjust it constantly. But anyway, a small inconvenience. So this be like an overview video, I guess. Just going through some of the important points. You know, the ones that nobody's responded to, of course, and I don't think they can be responded to. You know, in terms of there's no, it's just the truth. And so I'll just go over some of this basic stuff. All right, so first sentence is impossible for me to read at the moment. No source of energy for magnetism or gravity. And that also goes for the nuclear forces, but I didn't include that. But so all these major force events that take place in physics, the ones that are substantially invisible, they don't have to account for the event because all the events are sort of enclosed systems. And so energy conservation means they can just pretend there wasn't any energy. Which is a lot like saying that, let's say you're in medieval times and you have a giant catapult and you're going to catapult a brick onto the castle wall. The argument sort of is, well, because the catapult doesn't shoot anything into space, that from space there was a non-energy event, because all you did was transfer energy from one place to another, and so therefore we don't have to account for it because it didn't affect the universe in some way. And so they do the same thing essentially with magnetism and gravity. They claim basically we don't have to account for the fact that the Earth is actually moving and the sun's actually moving, and there has to usually be a force that makes stuff move. You know, you have to account for it. You have to show where the rocket engines are. If you're going to say the shuttle's going to go out into space and then come back down, we all know you have to have force to do that. And yes, the force will be recollected when the shuttle crashes to Earth, and depending on how you crash it, of course. If you crash it fast, it'll be a big boom, and if you crash it slow, you burn up a lot of atmosphere, heat up a lot of atmosphere, in terms of returning the energy you used to shoot the shuttle. So anyway, so gravity and magnetism and the nuclear forces all have this problem where they essentially borrow the energy. They just say, well, it comes from nowhere and we'll put it back to nowhere, you know, after we're done using it. So in the real nuclear physics, the very small particle physics, there's a classic, you know, Feynman kind of diagram explanation of we'll just borrow it from the future and use it, and then we'll return it in the future. So we'll just take pretend energy borrowed from the future, make something happen, and then we'll give it back in the future where, yes, we'll account for it. And it's because we know we're going to see it in the future. So I guess that's sort of the thing. We're going to see the consequence of the energy, so somehow we have to put the energy in because we know we're going to get it out. So we know the event is going to create something that looks like energy, and so somewhere we got to figure out where it came from, and because they can't figure out where it came from, they just pull it out of the future and pretend it's pretend energy. And in magnetism, there's the classic virtual photon that they invented, you know, to this virtual thing that does the energy thing, which is transferring the energy. And in gravity, it's the bend space well. Like I said, everything's a closed system, so they don't have to account for the uses of any energy, the consumption of any energy, but they're just pretending that there's no need to have any force that actually pushes anything. And if you're serious about physics, I think you do want an explanation of why the little bits inside of the Earth move towards the sun, or why the little bits inside of you move down towards the Earth, because you're not going to burn any energy to move. If I drop you in the atmosphere, there's no energy inside of you that is consumed to push you into the Earth. There's no rocket engines. It's just that simple. And clearly we know that forces should be it just seems logical. You've got to account for movement. And so that's a later statement in here, but we'll move on. Should be understood. So I would argue that magnetism and gravity, movement of material bodies, should be understood as filters, not sources of energy. So in the magnet, it's quite obvious to think about it in terms of it's just a filter. So all the magnet is really doing is changing the force that comes in, and in a sense, by segregating it, these two forces, proton force, electron force, sensitive force, that it magnifies its effect, because now it's not being diluted. So it's just as kind of obvious as thinking in terms of the idea of the repulsive force of electrons and the repulsive force between protons, and just understanding that if you segregate those forces, if you had them all mixed up and you shot that force at a proton or electron, it wouldn't be near as effective as if you concentrated the force and shot it at an electron or a proton. And so what a magnet really is just doing is it's filtering an energy that already exists in the environment, and that energy is what it's magnifying. By segregating the elements of that force, it's concentrating its ability to affect protons and electrons specifically, as I will explain later. Okay, so in the Earth model, the best way to think about it is they absorb their movement from movement already in the environment. So there's a bunch of energy in the environment, invisible energy, like radio waves and microwaves and cosmic rays and X-rays, except they're not in this ray form. They're not in some set frequency point source coming from some specific thing. They're just like the microwave background radiation. They're a background radiation that's constantly bombarding everything, and it is because the Earth or the Sun filters out some of that energy, absorbs it, that it gains its movement. So everything's movement is a function of it collecting some force, and it either collects it in a permanent way or an impermanent way. I would argue that electrons and protons can't collect it permanently, but things like neutrons can, by having their relationship to each other perverted, stretched, and they will process in the direction of that stretch. Don't want to get into too much specifics here. I'm just making the basic point that physics doesn't explain this now. Conventional physics uses cop-outs and bizarre, borrowing from the future, kind of nonsensical explanations to explain the force mechanisms involved in these things that are obviously forces. Magnets, a steel nail moves towards a magnet. There's a reason it does it. There's energy somewhere that has to be absorbed for it to move, and they just don't explain it. So in each one of these categories of movement, in the big thing, galactic way, they pretend they can eliminate, move space around, so they can take the space between the Earth and the Sun somehow and extract it, and the Earth falls into the empty space. In magnetism, I don't think they really use that excuse. Again, they invent these invisible photons, these virtual photons. They're doing exactly the thing I'm describing, which is emanating from the magnet because the magnet is filtering them out of real space. And so they create a real particle type force, but they don't have the guts to say it's a real thing. They call it a virtual. It's a pretend, a placeholder force. We don't know, so we'll just call it the magical. It seems like it could be some kind of elemental force because that works for the mathematics. And as I pointed out with Maxwell, they use the word wave, but Maxwell's science, it was all about vectors and the idea that, of divergence and the idea of diverging vectors. And so you could understand that if I took anything and I only said you could only have 10 radiuses come off of that thing, you could understand that as you go further away from the thing, the radiuses get further apart. And that's all of Maxwell's math. It's all about being able to describe any point in space by measuring how wide the different elements, the force that reaches them is. The force could be this wide from this particle, and it would be this wide from this particle between the rays, the 10 rays it's allowed. And so Maxwell did the simple calculation of saying this is 2 elements, where in here there's almost, only say 0.75 of an element if you average the distance to how many fingers end up showing, or affecting something. So you're just measuring the distance. So anyway, there's no wave involved. Anyway. Alright, so force doesn't interact with force. As a basic principle, understanding that you can't make the forces interact with each other. They have to interact with a material thing. You have to have a piece of matter as a conduit. The forces themselves can't do anything until they start reacting to the material thing that the force might be emanating from. But they have to actually interact with the matter. And so when 2 matter bits interact with each other, like 2 protons, the forces aren't really interacting with each other. The protons will bounce off of each other, slide off of each other. They won't hit because the forces will take care of that. But it won't be because this force interacts with this force. It'll be because this force interacts with the matter of this force. And the force coming off this will interact with the matter of this force. So they won't really be able to interact with each other until those forces actually can hit the matter. And the same is true for gravitational effects. The gravity doesn't add up, and then the gravity forces interact with each other from each body. The interactions always have to be with the force getting to the body, and vice versa. So there's just no evidence that it's like as simple as the light experiments, where you can't get 2 rays of light to bounce off of each other in any way, because light is actually a force, like all the other forces, and it just has one property that makes it different, which is at a set frequency thing. The force comes at a set frequency, and a specific one for visible light, and the rest of the force outside of the electromagnetic spectrum isn't produced the same way, and therefore doesn't have that frequency, because the frequency is created by a specific circumstance, which I'll go into later. Alright, so force affects matter, matter affects force. So that's basically what I just said. But you can just think of matter almost as matter bits. So you could almost think of the electron and the proton as nothing, just something different. So it's like oil and water. The force is oil, the matter bits are water. They can't combine with each other. They can't. They're just by nature repulsive, in the sense that they'll react to each other. Force bit will bounce off of, or in some way interact with the matter. And so you could think of matter as almost being nothing, and it's just a conduit between all the forces that bounce around the matter. The only place that changes, again, is, as I stated, with when matter achieves perpetual motion. When I push a piece of matter into empty space and it keeps going and keeps going, it keeps going because it has the force inside of it, the oil, so to speak, in the sense that the force has changed the directionality of the actual physical properties of the matter. The matter is physically changed in the sense that those neutrons are all stretched in the direction of the motion, and therefore they keep processing in that direction. And they'll process in another direction if you hit them with force and bend them in another direction. So it's just about bending the distortion of neutrons that is fundamentally creating things that keep moving. But most things don't really keep moving because there's always some other forces that are going to affect them. So it's hard on Earth especially to throw something in a forceless environment. So it's only when you really do it in space that you get the real idea of this idea of perpetual motion, that it'll just keep going until some force acts on it. Not until some matter acts on it, but some force that, yes, usually has to be emanating from matter. Alright. All velocity originates with the velocity of force. And that's related to the speed of light is the speed of force. So all the forces move at the speed of light. This is a fact. It's been around for a long time. And physics, conventional physics, didn't pay it much mind. They didn't think of that as being a significant truth that they should pay attention to. That might mean something. That, you know, magnetism and gravity are moving the same speed as light. And clearly light has such a clear connection to a particle fact, in the sense that there's tons of experiments that demonstrate the quantized force bit of light, that it's a little tiny bit. When it lands, it's a little tiny bit that delivers a discrete amount of energy. It is not a wave, and it's not spread out, and it doesn't flow into something like water coming out of a pitcher or something. It comes in clumps, as Feynman would say, discrete clumps of specific energy. And clearly they should have taken that and thought, well, what if gravity was discrete clumps? What if magnetism, the effects of a magnet, the filtering the magnet's doing, was creating clumps, segregated clumps? The fact of this polarization thing, the idea that there's two kinds of force bits, like there's two kinds of matter bits, is just the simple recognition that charge exists in the universe. And charge is the same thing as magnetism. Electricity is not really a force. Well, maybe I'll get to that later. It's the consequence of a force. It's the movement of matter, material bits, electrons. And they're moved by magnetism, not by electricity. But anyway, proceeding. So all velocity originates with the velocity of force, which is another way of saying, too, that everything collects it. Like I said, if this pen moves, it's because it's the force moved through my arm, through everything else, and then moved into this thing to move all of the little matter bits in it, because they're all tied through tension. But it was the little bits that are the origin of the velocity. So if something has velocity, it moves. It's moving because it's got energy in it in some different proportion. And it moves something like, I've used this analogy, a school of fish. You understand that a school of fish can have no motion, but all the fish are moving. It's because they're counteracting in direction each other. So if a school of fish isn't moving, it means that there's just as many fish going one way as there is going the other way, as there is going this way, as there is going that way. And they're all doing, on average, that same circular movement. And it's not until you add more something going one way that it mixes into the blend of the school of fish and causes the effect of the school starting to gain motion. Now, if I took a 50-mile-an-hour fish and put it into a school of fish, the school of fish won't move 50 miles an hour. It'll just take that 50 miles an hour and divide it over all the fish and move maybe 1/50th of a mile an hour. And that's basically what's happening when we absorb force. We're absorbing the speed of light, but we're only just absorbing it in these little tiny, tiny bits. And those little tiny bits of mass have to be divided over our entire mass. And the speed is proportionally reduced by how small the bit is compared to the total mass it's moving. So if one photon hits me, the mass of the photon is so infinitesimally small that when you balance that speed over the trillions or gazillions of mass elements equal to a photon that are inside of me, you only get motion out of my entire body that would be infinitesimally small, because the speed of that light has to be divided by the number of elements it has to move. Equally massive elements. Alright, to change its direction, a photon must interact with a material bit. So it's again just going back to the fact that photons are force, and it's the force rule. Forces affect matter bits. Matter bits block, absorb, interact with force bits. They're two opposite things in a sense. And in the real game, all of the energy, the intrinsic movement, the movement that exists fundamentally, is in the little bits, the photons. They have the tons, the force bits. They have the speed of light motion, and it never goes away. And all you do is change where that force bit is moving. When an atom absorbs a photon, it's really just collecting it in the pressure between the electrons, and it just becomes a piece of the pressure between the electrons. And that's entirely how everything really functions. That's how a battery works, is you're not just adding electrons, you're adding the force between the electrons. And that's the moving bit. That's the bit that can do power, can do work, can make things move, is that force bit. The electron doesn't make things move. The force between the electrons is what makes things move. Alright, looks like is not is like. This is like a huge problem in physics, and you could kind of see it with Piro. I mean, it seems like, it looks like, it seems like, looks like. And yeah, we all do it. We all have to be really careful, and I would argue that physics wasn't at all careful, in that anything that looked like something, they just jumped too fast, on too little evidence. They saw the abominable snowman because they wanted to see it, not because it was really there. Mirages became realities, and this is so true with all this idea of comparing wave phenomenons in oceans or anywhere else, in liquids, in mediums, and comparing that to the force dynamics of how force interacts with matter. And they have just this idea of a on-off pattern, bars, the simplest pattern in the universe. And yes, interference waves can do that, but lots of things can create on-off. And because it looks like something doesn't mean it is something. And it's just a huge mistake that was made in physics, is not really appreciating looks like isn't good enough. Anyway, so a wave is energy passing through connected tension. So this whole idea that they've defined waves, they've completely opened the definition of a wave into all kinds of things. And a wave has to be understood that I can have a wave of soldiers, I could have a wave of bullets, I could have a wave of a lot of things that we'll call a wave. And they're not really waves because each one is an individual. None of them are tied to each other. They can go at any time in different directions if provoked to do so. And a wave is really dependent on the idea of tension. So you could create a wave inside an atom because all of the little bits of the atom are magnetically tied to each other, and they're all in a rigid tension. They have kind of rubber bands of force between each other, and any movement in one bit will move the other bits. They'll all vibrate. So any vibration, any change in one element is going to be spread over all the others because they're communicating, and essentially they have these kinds of strings or ropes or whatever you want to call it tied to each other. So they're in tension. But the individual bits aren't in tension. The force bits are never in tension. They're never tied to each other. So certainly you could shoot a bunch of photons all at the same time, at the same exact moment, and shoot them into space. Shoot them all at once. So they're all in phase with each other. And it can look like a wave, but there's nothing tying them together. There is no wave. There's no medium tying them. They just have the appearance of a wave, but they won't have the function of a wave. because when they do hit a surface, or they do hit something, they're not going to hit it as a wave, in the sense that they're not going to, one of them isn't going to hit and it tells the other one I hit something, the other one reacts because it hit something. It's not going to spread the force over a distance. The individual soldiers are just going to hit like individual bullets. There will be no wave effect. If I shoot 10 bullets out in directions in a wave, and only one of the bullets hits you, all you're going to feel is one bullet. The rest of the bullets are just going to go. There'll be no wave effect. There'll be no tension between the bullets, no spreading of any forces. So it's just a huge imprecision that physics allowed to exist in the way it uses the word wave, because it's now anything that comes at a frequency or a period is a wave, and it's not a wave. A wave of bullets has nothing in common with a sound wave or a water wave. Nothing in common except appearance. But everything mechanically about it, it will not act anything like a wave. So, I say the obvious I already stated, force bits have no connected tension. So you can definitely shoot force bits in rigid, regimental configurations, and they can have every appearance of being connected, but it's just an appearance. There's no real tension between them. They're all free agents, and they're only going to act as individual agents with whatever they encounter in the future. Alright. A wave of photons is as wrong as a wave of bullets. So I'm just pointing out that a wave of bullets is nothing like an ocean wave. It's nothing like a sound wave through a metal, or a sound wave through the atmosphere. Has nothing in common with those things. Alright, move this up a little. Okay, that should be, yeah, that's enough. I can see the rest. Alright, where was I? Okay, the surface experiments. Okay, so now we get into the slit experiments and diffraction of light experiments and the interaction between light and material objects, surfaces, diffraction, gradients, edges, whatever you want to, however you want to think about it. And so they applied this wave phenomenon, and yet if you just dissect the evidence that exists, you can see that it's not a wave phenomenon, that there's no source or a rationale for the real phenomenon. So the factual truth is that every surface can create some diffraction. It's just really difficult to see it because you don't have another surface confining how much light creates the pattern. But if you took a black opaque thing and you shine light on its edge, you will actually create the same pattern as you get in a single slit experiment, for example. It's just that the percentage of the light, the problem is that there's too much light gets over the edge. It's too hard to take not just a few photons over the edge. So in most experiments, but the ones they have done, you can see that there is single surface diffraction, and it creates a pattern. So it's a surface phenomenon, in my opinion, clearly. And so then what do you have when you have two surfaces? Okay, we call that the single slit experiment. And the great advantage of that experiment is you can confine how much light goes through. And so as the two surfaces get closer, you can understand that the volume of the total volume becomes more and more likely that you'll be a photon that'll be near a surface. And it's really clear with an aperture. So if you make an aperture smaller, you can see that a number of photons that would come near a surface gets higher and higher as a percentage of the light as you make the aperture smaller and smaller. So this is about contact with matter. This is about a force, light, making contact proximity contact with material objects. So you can really see this in the double slit experiment, as I showed in the video before last, I believe, where you can have a single wire experiment, and it'll create a diffraction pattern. It'll create an interference pattern. It's two surfaces. So just like the single slit, it's two surfaces. And the real key is again, how much light is as a percentage is going over the surfaces. So the advantage of the single wire experiment is you can control how much light hits the impediment and try to maximize. Instead of just having one surface creating the phenomenon, you'll have two, which gives you some advantage in terms of seeing the pattern. But all it really is about the surfaces. The surfaces are creating the pattern. The surfaces are creating the pattern in a single slit. And as I pointed out, often the mask doesn't really duplicate the actual pattern you see. It's very barred instead of flowing on and off, gradually on, gradually off, as it should. And these are all pieces of evidence indicating they have the wrong theory, that this isn't about interference, light interfering with light. This is about light having something happening to light when it goes near a surface. I mean, again, the small aperture just demonstrates that all that's happening is you're increasing the likelihood that the photon traveled close to a material surface. And that's why you're getting more and more diffraction spreading, is because more and more of the light actually went close to a surface. And the surfaces, I would argue, are crowded with electrons. And the photons are hitting electrons. And it's a perfectly sensible explanation. So in the two-slit experiment done with a thin wire between the two slits, these two surfaces become irrelevant, and the only thing affecting the pattern is the wire. But if you do a real two-slit experiment, with two openings, then you have four surfaces. And that's all it's really about. It's not the two-slit experiment, it's the four-surface experiment. And you have a much more elaborate pattern because there's four surfaces affecting the pattern. And I won't go into the details of that because it gets into this whole idea of charge and the fact that you're changing the charge or the arrangement of the electrons as you change the distance between them. In the two-slit experiment, you have two slits of a specific width rather than one big slit, and so you have a different charge for in the sense that the two opposite slits will have different charge properties based on the fact that there's a difference in the medium between them. It's a refractive index. There's a substance in between the atoms, and the substance between the atoms causes the electrons to change their pattern because the atoms don't have the same pressure. So the electrons in the material thing have a certain pressure. The space between the two slits is of a different electron pressure, and then you have the atomic pressure of the atom again, and that space has to be balanced with the space of the other atoms, because that's what electrons do. They balance their pressure. Alright, so the single slit, two surface, four surface. So I sort of pointed that out, so I sort of talked beyond my sentence there. But that's what you really have. These are surface experiments. And again, the case can be proven because using high quality optics and all that kind of stuff, you can get a diffraction pattern off a single surface. And it'll be much like the pattern you get off of a single slit. Okay, it looks like interference, but it isn't. So that's the key thing. It looks on, off, on, off, on, off. Okay, it looks like something, but it isn't. Alright, with visible light, the effect is caused by electron deflection. So I'm going to use the word deflection because I want to get into refraction and reflections and all that nonsense. The idea is that the force affects the electron moves, and that means the force between the other electrons it's associated with. Electrons are always associated with other electrons or a proton. They never exist in some sort of free space where there's no charge field. There's always charge. Everywhere you would put an electron in space, it would feel the difference between some place here and some place there and some place over here. They all have different static charges, and the electron will feel it. It'll feel the difference in the force pressure, and it'll move based on that force pressure. So when a photon hits an electron, it artificially gives it momentum. That new momentum might be against the forces that are affecting it, in the sense the electron was in its happy place. The photon moves it out of its happy place, and the electron will probably be pushed right back to its happy place again. And that motion releases a new bit of energy in a new direction. So again, I've gone into pretty detailed explanations of the idea that the electrons on the surface of bodies have a probabilistic amount of movement. They move because the photon hits them. That movement will create a specific angle, and all the slits is essentially copies at different locations. So you hit one electron, you move 4 degrees. You hit 2 electrons, you move 8 degrees. You hit 3 electrons, you move 12 degrees. You hit 4 electrons, you move 16 degrees. And that's all it really is. It's just a simple pattern, probabilistic, because of the odds are you're not going to hit 4 very often. That's why there's very few way out there. The odds are you'll hit 3 more often, you'll hit 2 even more often, you'll hit 1 even more often, you'll hit none even more often. That's why the middle has more light. But it fits the probability math. It's a simple solution to this, long pretended to be conundrum of figuring out why these particles are acting like a wave. They're not acting like a wave. The electrons are acting a little bit wave-like, in the sense they're communicating with each other and spreading their force. The pressure between them is forcing them to achieve a balance and to maintain a balance, and the photons are disrupting the balance of the electrons. Okay. The effect is caused by electron deflection. Okay. In microwave and radio wave experiments, the effect is caused by jamming of the signal. So here I'm calling them microwaves because that's what they've called them, but they're not really waves again. And radio waves because that's what they call them, but they're not really radio waves. They're made up of discrete particles, discrete entities that move the speed of light and move entirely independent of each other. They have no connection to each other whatsoever. And only the material universe, only the pinball machine they get bounced around by, will change their direction. So in the radio experiment, it's a completely different thing. They're not really using surfaces, to create barriers, to create material obstacles that will cause the light to be diffracted. Instead, they're just creating two different sources that are at exactly the same frequency, and they're just pumping the signal out from two independent sources, and they're just creating differences in the fact that at any one location you'll be closer to one of the sources than you will be the other, which means the two signals will become out of phase, and then they'll become enough out of phase that they're completely in phase again because they're a whole wavelength off. So you can put them in phase by just going whole wavelengths of distance, and at those whole wavelengths of distance you get a signal. When they're 50-50 out of phase, you don't have a resolvable signal, and the key word there is resolvable. The signal's still there, the energy is still going there, the photons are still going there. You just can't receive the signal because it's jamming. One radio signal is jamming the other radio signal by the half frequency difference the two signals are at, which creates a new frequency. I mean, if you have something at this frequency and this frequency, and then you put them on top of each other, the new frequency is much faster than the old frequency. That's twice as much frequency. So if you're just tuning this frequency and this frequency shows up, you're going to throw this frequency out, even though that's made out of two of these. You can't see it. So that's the experiment. Is, again, they've just been completely deluded, fooled by the phenomenon. They've jumped to a conclusion, and the very fact that they have to, kind of create their experiment to fit the circumstance. I mean, I think it's quite clear that I think in the process of building these experiments, they had to realize, they probably did really notice, that they can't detect this interference pattern unless they put a carrier signal on the signal. Because if they just use a detector that picks up the energy of the radio signal at any frequency, that's a detector that can detect any frequency, just detects how much energy is hitting it, that detector won't see any interference pattern because it doesn't exist. There is no interference. They're just jamming one radio signal with another radio signal. And it's just a simple answer. And I'm just saying, part of this is just, bandwagonism. Everybody jumps on the bandwagon. Most physicists never do the actual experiments, so they get fooled by experiments that have been engineered over decades to be good for demonstration purposes. These are demonstration purpose experiments. But the fact is, if you pick at these experiments, you modify them a little bit, they could see the actual truth. And I think some of them did see the actual truth, but they were so programmed to think that can't be right. Oh, it can't be right that I'm seeing exactly the same much energy hitting all these locations. There's supposed to be a bar pattern. And they're just programmed to think, well, I must be doing something wrong. I'm doing the experiment wrong. So yeah, I better do it this other way where you can see it, because it must be there. It's like their programming is just so rigid and so controlling. They've just been taught to think anything, any alternative theory is to be despised and hated and dismissed. Anyway, moving on. Electrons and protons are the magnetic monopoles. I mean, this is another thing I just can't believe that physics hasn't occurred to physics to see this obvious fact. And Professor Lewin even said I'd get a Nobel Prize if I can find a magnetic monopole. And it just seems so obvious. Yeah, I can find two of them. Protons and electrons. I can't even imagine what anyone's counter argument is to the fact that we already know this. I don't know why they haven't stated it overtly. It's time to just forget about this electric crap and just recognize that the magnetic monopoles, because we already know that's what's causing magnetism. We already know that the magnetic filter, when you make something magnetic, that what you're doing is you're taking the two monopoles, electrons and protons, and putting them at the opposite ends. You're creating the magnet by putting all the protons pointing one way and all the electrons pointing another way. That's how you're making the magnet. How can those electrons and protons not be the magnetic monopoles when you actually have every diagram points out the fact that that's exactly what you're doing? You're lining up atoms with their neutrons and protons in an imbalanced state. It's so obvious. I mean, this is the kind of thing where you just say, they're just reading out of their Bible. I mean, they're not even taking any time to say, well, maybe there's some other kind of God. Maybe there's some other, maybe we could be Methodists instead of Catholics. They're not even trying to be Methodists. I mean, they are so stuck in the regiment, so stuck in one interpretation of reading every sentence out of this book of this dogma of wave theory, that they can't even migrate a tiny bit out of the blinder, out of their focus to recognize something so obvious. Anyway, magnetism is the force behind all electrical phenomena. So electric just means moving electrons, and it doesn't really mean moving them. It just means moving them. It just means moving them. It doesn't mean they have to go somewhere. Now, sometimes they do go somewhere, because the force is pushing them and they're going to go. But a lot of times when we say something's moving, it's not really moving. They're just vibrating. They're just going back and forth. So an electric current, for example, an AC electric current most especially, the electrons aren't moving anywhere. They're just vibrating back and forth. Well, they're vibrating in and out, actually, but I don't want to get into the details. They're going in the wire and then out of the wire and in the wire, out of the wire. And all that represents is a change in pressure. When they're in, high pressure. When they're out, lower pressure. High pressure, low pressure. High pressure, low pressure. In terms of the amount of force between them. They're full of force when they're expanding. It's because there's a lot of force, and it's pushing all the electrons away from each other, and the electrons are expanding out because there's so much force being forced between them. And that's a high voltage, a high potential, high electron pressure. Anyway, magnetism is the force behind all electrical phenomena. So yes, it's the magnet creates the segregation. The segregation is what gets absorbed by the electrons. They're only absorbing one kind of. There's only one kind of energy between electrons. I don't want to get into the complexities of this, but between the electrons, the little force bits are going back and forth. So the further away they part, slower clicks. The closer they get together, the faster the clicks get. And each click represents energy. So you're increasing the energy as you increase the proximity, the closeness between electrons. It's just a way of increasing the energy, in a sense. It's not an absolute increase, but it's a grabbable increase. It increases the capacity for us to take the energy quickly. The further away apart they are, the harder the energy is to get. The closer they are, the easier the energy is to get. It's not like it's technically more energy. It just has to do with the spatial relationships between the electrons. But that's all. The force, the fact that the electrons have the black force reflects between them, and the protons, the red force, reflects between them, and it's just segregated. One force affects electrons, one polarization affects protons. And it's that simple. There's two kinds of matter, electrons, protons. There's two kinds of force, electron force, proton force. Alright, there is no electrical force. So again, the force between electrons is magnetic, segregated force bits. The ones bouncing back and forth between the electrons are all the same kind of force bits, and the ones bouncing between the protons, forcing them apart, are a different kind. And when you mix the two, when proton force hits an electron, it leaves perpendicularly, and likewise when an electron force hits a proton, it leaves perpendicularly. It doesn't reflect. Alright, the force bits between electrons are magnetically polarized. So it's just, again, just emphasizing it's the same effect in the sense that magnets are basically just emphasizing the point. They're creating all the electron force out of one end, all the proton affecting force out of the other end. So when they come in contact with matter, what they're doing is pushing the protons, you could argue, from one side and pushing the electrons from the other side. And so let's see how to say that. So the end result will be that the electrons will be free on the proton side, and the protons will be free on the electron side. Where you push the electrons down, you're kind of letting the protons move out. When you're pushing the protons down, you're letting the electrons move out. So you're polarizing the surface of the material when the magnetism is affecting it. And by polarizing it, you're moving the electrons. And by moving the electrons, you're likely going to move the force bits between them. And again, it's basically just expansion and contraction. Where you compress the electrons, you compress the force between them and create higher pressure. And that's voltage. Okay. The higher the pressure, the higher the likelihood of higher frequency. So it doesn't guarantee. You can have high pressure in two ways. I can put more little bits to, so think of it as ping pong balls between two surfaces bouncing back and forth. There's two ways I can make it more energetic. I can just move my hands together and the ball bounces back faster and faster. Or I can add more ping pong balls. So if I have 10 ping pong balls bouncing between something, there's going to be more pressure than if I only have 5. It'll double the pressure, clearly. More impacts. Impacts are pressure. Impacts are energy. And realized. And so there's 2 ways you can increase pressure. Put more ping pong balls in, or narrow the gap between the walls. So, but I'm just saying as a statement of likelihood. The simple truth is if you move electrons closer, you're going to increase the pressure, which means you're really increasing the bounce frequency. And what's bouncing between the electrons, as the next statement should say, reflections of pressure, are the photons. And so this is the mechanism that traps and releases photons. So photons go into a system, they bounce off an electron, let's say, and then they get caught between 2 electrons and they become pressure that constantly hits the electron. And when the electron moves, that pressure can be released to the atmosphere. And so it's all about how electrons are lined up with each other and how much pressure is trapped between them is dictating the entire life cycle of photons. Photons live most of their life. Okay, all the photons that hit you or get absorbed by you or turn into heat or all this other stuff, a ton of those photons, when you absorb them as energy or something, they're just being, like in a plant leaf, the photons come in, and the plant leaf has a sophisticated system of channeling the photons so they don't bounce off. And so what they really do is get trapped between the electrons. And so they're collecting the photons. And that's the energy they're collecting. It's just collected photons. And so a plant 300 million years ago gets hit by sunlight. It collects a bunch of photons. And then it decomposes and does lots of things. But those photons don't escape. They stay in those material and atomic structures. So they stay in those atoms, and it slowly becomes oil, and then 300 million years later we pull it out of the ground, and those photons are still in there. The solar energy trapped 300 million years ago, the little photons hit it, and they stayed in there for 300 million years. And then we free them by breaking those atomic bonds, the chemical bonds, and all the little photons come flying back out in the form of infrared radiation or some other radiation we can use to boil water and create pressure and blah, 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 blah. But that's it. That's the life cycle of photons. The entire universe runs on the life cycle of these little force bits that the universe is full of. And the little matter bits are just being bounced around by the pressure of the force bits. Alright, enough of a video. So yes, this summary lacks images and different things, but I'm just saying this is a summary of the biggest flaws in regular physics, in conventional physics. The unanswered questions. They have no explanations for the phenomena of magnetism. They have no explanation really for gravity in terms of any understanding of any kind of mechanism that actually makes the material bits move. I'm made of matter. I'm made of atoms. I'm made of electrons and protons. They have no explanation for how those electrons and protons know that somehow they're supposed to be sliding down some bent space well. How do they know it? What provokes them to do that? They have no explanation. If it was a regular kind of slide or something, then my feet should want to slide faster than my head. Why does my head want to come down just as much as my feet want to go down? Well, that's not entirely true. There is a little more gravity on my head than there is on my feet, but regardless. It's just a silly explanation of force. It's a silly physical explanation, this vacuous notion that we have we've taken the inverse square law, a simple principle of how force diminishes as it spreads out, how it gets thinner. Just like a balloon's thickness. A balloon is really thick when you don't blow it up. When you blow it up, it gets thinner and thinner and thinner and thinner. And if you could keep blowing it up, it would get just tiny, so transparently thin. And that's the same thing that's happening to force. As you blow the balloon up, the force gets weaker and weaker because it's more and more spread out. So he takes a simple idea like that and turns it into some dopey well, and you all fall for it, as if somehow that's why we fall to the earth, is because we're somehow sliding or falling down some silly slide. We're sliding. No real energy necessary. Come on. It's just such a weak explanation. Why don't you want an explanation that's solid? Yeah, something real, not virtual, not bent, real stuff, not real physics, not made up wooey bullshit. Anyway, I mean, I can't make you be reasonable. All I can do is make the reasoned argument. So I think I've made the reasoned argument. I've pointed out the huge flaws in conventional physics. How do you explain them? How do you counter-argue any of these points I have made? Please, give me the counter-argument. Don't give me some bullshit link to a bullshit article that doesn't say anything. Explain how each one of these, any one of these sentences, any one of these statements can't be right. Show me the experiment that says it's wrong. Show me the experiment it's in conflict with. Alright. I mean, I didn't go into, I mean, some people bring up time dilation or something. That's explained just simply by the simple metaphor that if you're dancing as fast as you can, like an atom's doing exactly as much as it possibly can. It can't do any more. And then you make that thing, if you're dancing as fast as you can, I say, dance to the left. Well, you won't be able to dance as fast because you have to waste time moving to the left. And that's time dilation. Every atomic process, when you force an atom to move, you change its metabolism. The atom actually has to drag all the pieces in that direction. And while it's going in that direction, while it's pulling, all the little forces between all the electrons are pulling and changing, and it's readjusting all of those tension lines between each other, the force bits between each other are all stretching and tensioning. That takes time. And so everything else it was doing gets slowed down because it doesn't have time to do the other stuff it was doing at the same speed, because it's got to waste a bunch of time moving. You don't need to warp a dimension to explain time dilation. The fact that clocks don't work when you're moving them. Damn. Anyway. When consistent mechanisms are no longer consistent mechanisms when you force them to be moved, because the bits inside of them can't consistently do what they were doing if they have to spend time moving. I mean, it's just so simple an explanation. Alright, enough pleading. Please be reasonable.